Hello students, this is Mr. Flora. So I know some of you had been struggling with the rule of 70, one worksheet we've been going through, so I figured I'd make a little video so we could go over it a little more. So, I'm going to assume that if you're curious on how we got the rule of 70, you watched the video on how to derive the equation. So I won't cover it in this one. I'm just going to go through the 5 problems here. So, to start off with, to figure out number 1, given a 2010 world population growth rate of 1.3% per year, how long would it take the world's population to double? By what year will this doubling occur? So, we got a couple important points here. First one is we have, so we're starting off our 0 year, our starting year is 2010, and we have a growth rate, or an R value, of 1.3%. And we're going to use our doubling time formula, which is dt, sorry about that, dt equals 70 divided by r. So we want to find the doubling time. So what we're going to do is to find the doubling time, our unknown variable here, dt, is what we're looking for, and our known variable is r with the 1.3%. Now, in this format, we do not need to convert this percentage into a decimal format. So, what we'll simply do is dt, the doubling time, equals 70 divided by 1.3. Now, when we plug this into a calculator, we'll get 53.85 years, or 54 years. So it takes 54 years for this to occur. Now, if we start off in 2010, and we want to know how far along, or what year this doubling will occur in, what we do is we're going to add our initial year, or our 0 year, so our first year here, or 0 year, which is 2010. So we have 2010 plus 54 years later, which will give us 2064. So that's our final year. So that's how we solved for number 1. So our answers for number 1 are 54 years for how long, and then what year is 2064. So now to move on to number 2. Now number 2 builds off number 1. Notice that both of them use 1.3% for their growth rate, and number 2, it's not stated, but it's implied that the year is 2010. So, number 2 is, if the population growth rate continues at 1.3% and you are 17 years old, how old will you be when the population doubles? So, we've already used 1.3% and figured out it takes 54 years. So, if you're 17 years old, so 17 years old now, how old will you be in 54 years? So, to figure that out, what we do is 54 plus 17 gives us 71 years old. So that's number 2. So now the next question we'll work through is number 3. So number 3 states, scientists and demographers are fairly sure the growth rate will slow in both developing and developed countries. With that in mind, if the growth rate averages about 1.1% over a doubling time period, how long will it take for the world's population to double? By what year would this doubling occur, and how old would you be if you are 17 years old? So this actually has 3 questions, but we'll work through it. So the first thing we're going to start off with is, what's the needed information? So the given information is 1.1 growth rate, and then you're 17 years old again, and now there's implied information that the 0 year, or the starting year, is in 2010. So our 0 year is 2010. So what we're going to do is we're going to use our DT formula again. So DT, or doubling time formula, equals 70 divided by R, with our R being 1.10%. So what we're going to do with that is use DT equals 70 divided by 1.01, which actually gives us 63.63 years, but I'm going to round that, round that to 64 years. So it's going to take 64 years for that to occur. Now, if this starts off in 2010 is our 0 year, we'll then add 64 years, and we will get the year 2074 as the final year. So we've solved 2 of the answers. So we have 64 years, and then we have 2074. Now, to figure out how old you would be. So in 2010, we would be 17. So in 2010, you're 17. So that, and remember, 2010 is our 0 year. So if we add that to 64, that's going to give us 81 years old. So this is our third answer for this question. So we'll come back here in a second and talk about number 4. So guys, welcome back. So for number 4, the doubling time for the world's population is 56 years. What will be the growth rate over this time? So we're given a little bit different information. So this time around, sorry, let me get rid of that box here, guys. So we're given 56 years. That's our doubling time. So we're actually given our DT is 56 years. But what we're not given is our R value. Our R value is the unknown. So that's what we need to solve for. So to do that, we're going to use our same formula. So we're going to use our doubling time formula with DT equals 70 divided by R. Now for 70 divided by R, our unknown this time is R, and our known is 56. So we'll plug in 56 equals 70 divided by R. Now we need to isolate for our R value. So to do that, what we're going to do is we're going to multiply both sides by r. So we'll multiply r on both sides. And what we're left with is 56r equals 70. Remember that we can move the r from in front of or behind using the commutative property. So we have 56r equals 70. So we're not quite there isolated, but we're getting pretty close. So what we're going to do is we're going to divide 56 on both sides. So we end up with 56 divided by 56 equals 1. And we end up with r, which equals 1.25. So this is our percent. Now, if we come over to number 5, which builds on top of number 4, and with number 5, I'll warn you, you gotta look for what's the useful information. A lot of the information in here is given to confuse you. So, the current world population is about 6.5 billion. Using the growth calculated in question number 4, so 1.25%, by what year will the world's population double? So we want to know how long it will. And then how old will you be if you're 17 years old now? And like it says here, don't be fooled, look for relevant information. So, the current world population is 6.5 billion. But that doesn't tell us anything. In fact, it's just there to confuse us. So what we're going to do is we're just going to put a line through it. Don't even need to worry about it. Just there to confuse us. So we're going to come back to the question and go, okay, so what's our question? Using the growth rate calculating number 4, by what year will the world's population double? So now we're just looking for when will the population double. So that's pretty simple. We have our growth rate from number 4, which is 1.25, and we want to know how long for the world to double. So we just do dt equals 70 divided by r. And all we're going to do is just plug and chug. So 70 divided by 1.25. And so if you plug that into your calculator, you'll notice it comes up with 56 years. So we found our first answer. How long will it take for the world population to double? 56 years. So we answered that first one. So I'm going to put a line through it just so we don't got to worry about it. Next it asks, how old will you be if you're 17 years old now? So, if you are 17 years old in the 0 year, so the 0 year, you're 17. How old are you 56 years later? So to calculate that, what we're looking at is, so in the 0 year, you're 17 years old. So we're going to do 56 plus 17, because you're 17 years old during the 0 year, so 56 years after that, which is 73 years old. So in the end, you'll be 73 years old. Well, I hope that was helpful, guys. Thank you for your time, and feel free to ask me if you have any more questions on this.